Some of you may or may not be familiar with the term data frame, and often the term does get thrown around quite casually, and it means different things to different people. So I wanted to try to give a definition of what is meant by the term data frame and how it differs from some of the other analytical tools that you might be familiar with. And so often when people use the term data frame, they might be referring to a couple of different things, or maybe some combination of them. So to some people, a data frame is more of a data structure. It's a way of representing, loading data into memory in a programming language that provides a medium for expressing computations. And so sometimes people think of it purely as being the data structure. For others, the data frame is more about the programming interface, the API that it exposes. And so, in practice, it's a combination of the two. And when people think about a library like Pandas, which is a data frame library, many libraries are providing both of these things. And so when people talk about data frames, it's sometimes you have to ask which part of the problem are they referring to. So this is an example data frame, kind of a built-in data set that's in R called mtcars, and you see the classic data frame structure of named columns and a tabular layout, along with some row labels, some metadata that identifies each row in the data set. In general, the columns in a data frame can be any data type. So here we have all numeric data, floating point numbers and integers, but you may also have strings or more complex types depending on the library. So the way I like to define a data frame is that, to me, a data frame is first and foremost a programming interface that may expose details of how it is implemented and details of the data structures that it is built on top of. But the thing that most programmers interact with and the people doing data analysis see is the code that they are writing. And so the code that you're writing is more important as far as defining the data frame than the low-level details of how the data is represented in memory. So the interface is about expressing data manipulations and data analysis. The data is almost always tabular or a spreadsheet. Data frames are distinguished by being generally used within a general purpose programming language. Programming language like R or Python or MATLAB. You have data frames in pretty much any programming language nowadays. I think it's not enough to have a programming interface that expresses data manipulations. I think an important distinction is that the primary modality of the interface is analysis, and so that distinguishes a data frame library from something like an ORM, object relational mapper, which people use to build applications and to create abstractions between database systems and object-oriented programming languages. Those two provide a programming interface to manipulate tabular data sets, but the modality of those interfaces is not the primary modality is not data analysis. I think something that sets apart data frames from traditional database systems is that they address many kinds of analysis problems and workloads that either are difficult to express in SQL-based systems, basically using the SQL query language, or that's difficult to express, or they may not be possible at all. And so I think data frame libraries, in particular over the last decade, have become kind of a catch-all for handling all of the different kind of analysis and data munging tasks that maybe are not being handled inside a data warehouse or a database system. Kind of getting into more technical differences between SQL-based systems and data frames. The API of data frames often are focused around imperative or procedural constructs. So there's more of an emphasis on iteration and expressing a sequence of operations in separate commands or separate lines of code that manipulate data structures or manipulate objects. Many times the data frames do expose details of how they're implemented. So they expose the internal data structures. They expose basically a lot more than a database system would expose, where in a typical database system, the only thing that is exposed is the query language. But the details of how the SQL queries are executed is not generally not available to the person who is writing SQL. Because of the flexibility of how the library is implemented, data frame libraries often capture implement operations which do not fit into the traditional relational algebra. So, in database systems, you have the kind of canonical relational algebra operations like aggregate, join, project, filter, sort. You see in data frame libraries operations where results are dependent on the order of rows in a table, or performing, for example, time series operations that takes advantage the ordering of records in a data set. I think another thing that matters a lot in interactive analysis is that the data frames are often stateful. They expose APIs that mutate the data structures. And so often the programmer is working interactively with a collection of data frame objects, performing manipulations on them and producing their analyses or data visualizations or whatever is their task at hand. So I'm going to jump into a Jupyter notebook here, and of course my server went down right as I'm doing my talk, so I will try to reload it. So in this notebook, I'm loading a bunch of Python libraries, and pardon me, nothing quite like a live demo. So in this demo, I have a CSV file that has a little over 2.5 gigabytes of data. This is a popular data set containing taxi fares from New York City yellow cabs. So I'm going to load that CSV file into an arrow table. I'll talk a little bit about what is an arrow table, and you'll see that I'm going to convert it to Pandas, which I'll talk about what that conversion means. And this is the first 5 rows of that table. And so some analysis that we might do, perhaps we are interested in determining the total amount of fares paid based on the size of the fare. So you might say, well, how much money did cabs make on fares that are less than $10 or between $25 and $50? So I have a little example here where I write down the bin edges for the fares that we're interested in looking at. Some people have really high fares over $100, so we can also look at those. We'll use the Pandas cut function to bin all of the fares and produce an array of binned data. And so the data has been grouped as a categorical type, with the categories being these bins. And then I'm going to group the data frame by the bins and select the total amount column and sum it, and maybe format it a little more nicely. And so we can see that the bulk of the fares are paid into the smaller fares under $25, and you don't actually have a lot of fares that are over $100. If we wanted to dig a bit deeper, we could also split out by the payment type. So whether people use cash or credit card. So we'll look at that. And so now we have, so we grouped by bin and payment type, and then I'm going to pivot the data to make it a little bit more readable. And so now we have a table where the columns are the payment type and the rows are the bucket of the fares. And so from there we could make a plot or do whatever we like. So that's kind of a simple example of what DataFrame APIs look like.